Hello friends, welcome to our channel. Today I will discuss regarding on RISC instructions with the example. Okay, RISC instruction with the example. RISC it is a one kind of a set instruction. We can write a short form of this RISC is a reduced instruction. Okay, reduced instruction set computer. Okay, reduced instruction set computer. We have already discussed in a different address instruction like a 3 address, 2 address, 1 address, 0 address. Okay, although those address contain sometimes a memory register or without that memory register like this, but it is another that is a techniques or approach, that is RISC instruction. Then how it is RISC instruction defined? Sometimes it is used memory, sometimes not used. At what time it is used or at what time not used, or only at what time both are used, we will see. So different approaches or different category of instructions are defined through reduced instruction set computer instructions. Okay, taking some example, we can define this particular category of instruction, that is RISC instructions. Okay, and the instruction set of this particular category, that is RISC processor, is restricted to use the load store instructions when communicated between that is memory CPU, because this instruction is not exactly as per the previous. Some restriction also there. What are the restriction? Whenever we will take some example, then I will explain. Okay, and other some instructions, suppose any kind of operation we operate or execute, like addition, subtraction or multiplication, whenever you execute, then what happens within the registers and the CPU without referring the memory. That means only register use, no memory is required if we go through any that is operations, addition, subtractions. Okay, some restriction also there. And another is the program for a RISC type of CPU consists of that is load, store instructions that have only some part is memory and some part is a register address, and the that is a computational type of instructions that have sometimes 3 addresses used. Whenever that is defined in a different ways, then we can find out how it is defined 3 addresses or 2 addresses like this. Okay, based on that we will define or generate different reduced instruction set as per the given instruction or arithmetic expression. Let us consider the arithmetic expression like this. Same expression, x is equal to a plus b and c plus d. Okay, same expression. How it is defined? Through that different instruction using RISC. Okay, now very simple way I will explain this one. Now you see, first of all this part a plus b, second is c plus d, and time to time I will consider. Okay, now start. This is how we will define this particular expression through RISC. Here first load. Okay, first load R1 A. Okay, load R1 A. In this case, what happens? One register part, another is memory part. If we go through load, so R1, we know that that is this kind of expression we can use if we go through this one. That means data transfer from memory having A to the register A, if we go through this one. Okay, similarly if we go through another one, load R2. Okay, load R2 B. So R2, here is the data transfer from memory for B operand, that transfer to register 2. Okay, similarly other also. First of all, you transfer all data what are the operand are there and load into the different registers. Load R3, here is C, okay, here R3 memory of C data transfer to R3. After that here also load R4, here is a D, R4, here is a D. That means whatever the number of operands are defined, okay, all operands are transferred to registers. After that we can use the registers, doesn't matter. So this is the one kind of advantage whenever you go through, that is a RISC instruction. No need to write, sometimes not needed for this memory, because all data transfer to register. You see A, B, C, D, all these operands transfer to individual registers. Whenever that data is required, then they will do that kind of through register only. No need memory. This is the advantage of this RISC. Sometimes it is memory register is required. It is required, but at what time it is required or at what time not required, then we will see. Some restriction for memory, some restriction for register, or at what situation it is needed, that we will see. Now that means R1, R2, R3, R4, the data transfer from memory A, memory B, memory C, memory D to individual register R1, R2, R3, R4. Okay. Now we will start. If we go through this one, addition of this A and B, okay, then what happens? What will do? Very simple way, add. Add first this particular addition we will do. Who will keep that data? That R1 and R2. Okay. So very simple way, that is 3 address register also we can use. Here is 2 address use. Same thing, 3 address register, 3 address instruction we can use. It is 2 address and 3 address we can use. No problem. There is no restriction of any number of addresses. R1, here we can write R1, R2. Okay, R1 and R2. Means what? 2 times written. That means these two R1 and R2 gives the data which is transferred from memory A and memory B. R1, R2. R1 is memory A, R2 is memory B. These data they are collected, and after this, or for this particular operation, addition operation, the data R1, sum of data R1 and R2 store in R1. Okay, store in R1. So in that case what happens? R1 contains R1 plus R2. Very simple. So here you see no need a memory no need for operation. If you go through operation, then no need of a memory here. Only through register we can use and we can operate. Very simple way. Okay. Similarly, here also we can write R. Here R1, R2. Here CD, R3, R4. Similar case we can write 2 times C, R3. Here R3, R4. Okay. Here R3. Here what you write? R3 plus R4. In this way we can write. Okay. So R3 plus R4. That means R1 store the data, sum of data R1 and R2. R3 store or keeps the data R3 and R4. This data it is maintained. Okay. Next, addition of 2 part is over. Next what happens? We will multiply. Then when we multiply, then what happens? Who keep the data? R1 and R3. This data. Again also use, since these are the operations. So 2 register use, but 3 ways it can write, 3 address mode. So here is we can write, that is R1, here is R3, because R2 gives the address of data, gives the sum of data A and B. R3 gives the sum of data C and D, and R1, R2 now multiply R1, R2 and multiply and store into R1. So now R1 is R1 multiply with R3. Okay. So this data now R1 contains that kind of data. What is the multiplication of R1 and R2? Now simple this data, after completion of that data or this operation, then what happens? Just that data transfer to any other memory. X is a memory. So now just use store data. Okay, use store data. What is store? Where is store? X. Okay, X, where it will store? From R1. So X, R1. Okay, this we need to explained in this way. So R1 data transfer to X. So very simple, MX, we use MX, the data transfer from R1. Okay, data transfer from R1 and store in MX, then memory. So very simple way. Here is a two. Here is a how many? Two variables with a two address mode. You see, two address mode for any load purpose. And here is, you see, similarly three address. Okay, here is only two. Okay? Only two address. So in this way, so both 2 and 3 address mode or instruction we define, and it also the transfer of data and how it is load, how it is operation point of view, the 3 address instruction will generate. If you only load and store point of view, 2 address we will use. This is the one kind of advantage, both 2 and 3 address instruction can be used for this RISC instruction. Okay, this is the best example for RISC instructions. With the example, certain example we take and evaluate accordingly. Okay, and I hope all of you understand this part. So thank you very much, and this is the very easy. We also, I think all of you understand this. Okay, thanks to all. Please subscribe my channel and like it, and if you want to give some comments, you can give some comments to my channel, by which we improve our videos and progress our channel. Okay, thanks to all.